In this video, we're going to look at how we differentiate. Now, I'll explain why we differentiate in the next video, but I just want to think about what is differentiation, how do we do it? So here we've got a curve, y equals ax to the power of n, and a and n are two constant numbers, and you can see we've got some examples to go here. When I differentiate, I use the term dy by dx. So the y differentiates into dy by dx. And I remove 1 from the power of x. So it's now x, and if it was n before, it's n minus 1. You take this value n and you multiply it by the a. So in front becomes a n. Now if that seems a little confusing, let's do it with some numbers. So here y equals x squared, dy by dx, because that's how we differentiate the x, the y rather. Then we do 2 times the number in front of x, and the number in front of x here is 1, so this becomes 2x. 2, take 1 away from 2, so it becomes 1. Now we don't normally write that, so it just becomes 2 to the power of x. Let's carry on. Oh, this one starts with fx, and when you differentiate fx, it doesn't become dy by dx. We use a different notation, which is f dash x, to show it's been differentiated. Now I'm going to do the same thing. I'm going to do 2 times the number in front of here, so it becomes 6x. Again, this is to the power of 1. I'm not going to write it because we don't normally write that. This x is to the power of 1, it's not written. 1 times 3 is 3. And then we have x to the power of 0. Because we had 1 and we took 1 away. Now we don't normally write x to the power of 0. That actually just becomes 1, so let's get rid of that. But that's the reason why it's 3 on its own, because this is 1 and it becomes 0. Let's keep going. Let's look at the next one. This one starts with y, so it becomes dy by dx. And similar to the 3x that turned into 3, this 5x will turn into 5. Now minus 3, let's just think about this. It's actually got an x to the power of 0 with it. Take the 0 and multiply it by the minus 3, and you've got 0. And it doesn't matter about taking 1 away from the power. This thing becomes 0 because it's 0 times 3. So this just comes out as being 5. So these constants, they don't have any x's, they just disappear. Finally, we've got one here. And this, actually, I want to rewrite this one before I begin. If the power is on the bottom, I can rewrite it to x to the power of minus 2. So when I differentiate it, I'm going to do minus 2 times the number in front, so it becomes minus 2x. Take 1 away, becomes minus 3. Now I can rewrite that as minus 2, and because the x has got a minus power with it, it goes on the bottom. So what I've got for you next is 4 to differentiate. If you want to pause the video, and then I'll differentiate them for you. Okay, this one, dy by dx, I do 3 times 3, 9x to the power of 2. This one here, now this one starts with f, so I'm going to use f dash x. 2 times x, so it becomes 2x, and then minus 6 at the back. The 1 disappears, and this is actually the power of 1, so it becomes minus 6x to the power of 0, so just leave it like that. This one I'm going to change before we start, so I'm going to change it into f. X is 1 times x to the power of minus 1. That's the x on the bottom. And then I differentiate it f dash x, and it becomes minus 1 x to the power of minus 2. So that goes on the bottom like that. Same thing here. I want to change this, and the square root is the same as the power of a half. So dy by dx times it by a half, and x, take 1 away from the power of a half, so we get that. And we can rearrange it. There's already a 2 on the bottom, and this is a minus, and this tells me to square root, so it all goes to the bottom. So that's more of a complicated one, and here with the minus one's how we deal with it. But these are two straightforward ones, and that's simply how you differentiate.